All right, folks, we'll get going here in just a minute. Working out the few little kinks we got here. Thanks for joining.
Now we just trip over one wire.
Yeah. All right. You good to go, Craig?
Yep.
All right, everyone. We're here with Mike Halbern, Sierra College professor of Mechatronics. And while some of you may know what that is, we'll go ahead and ask the first question here, which is, what is Mechatronics and what role does it play in our world?
Yeah, that's a really good question, David. I'll tell you, to answer that question with a bit of a story, because when I go to a dinner party, a cocktail party, the typical American social lubricant is, what do you do for a living, after your name? And I usually answer that, well, I teach. And then that is actually very much a course of study, both not just at Sierra College, but it was a standard technical curriculum in Western Europe and in Asia for many years. The term was coined by a Japanese engineer back in the 1970s at a company called Yaskawa. They make precision motor controls and currently they make robots. But it really means that we're dealing with systems that combine together mechanical things, electrical things, and computer things. And it's really everywhere. If you turn the faucet to get water from a municipal water supply, that water was treated using mechatronic principles. If you flush the toilet and the waste goes to a waste treatment plant, that plant is run by mechatronics. If you get into an elevator and push the button to take you from one floor to another, that's mechatronics. If you buy things that are manufactured using automation, that's mechatronics. So it's really the infrastructure of our country. It's really it's how stuff is made today, and people encounter it hundreds of times a day without giving it a second thought. And usually that's because it's pretty reliable. The things that you use that are made by mechatronics or provided to you, power delivery, waste and water treatment, elevators, ATM machines, etc. They all seem to work perfectly well all the time, but of course they don't. And the people that come through my program are really the folks that are responsible to install, to maintain, and repair equipment of that type. And it's everywhere. And that's the beauty of it, is that it is everywhere. So my job is to provide to students a set of skills, knowledge, and ability that they can apply in some enterprise that needs those skills to do the work that they do. And it's everywhere. A lot of my students, for example, will think nothing of going to the Lake Tahoe area, buying a lift ticket, plopping themselves on a chairlift and get hauled up the mountain so they can enjoy the skiing down the ski run. But that chairlift is completely mechatronics. And clearly in that system that monitors all those sensors and makes sure that nobody has to think twice about being hauled up the mountain and hanging in the chair hundreds of feet in the air, because it works very reliably and very well. And that's a good example of mechatronics. And the people that maintain those systems are people that come out of my program.
Well, that sounds just fantastic. Now, one of the things I heard you say is that people don't have to think about it. Now, this is all automated. How much maintenance versus initial setup is involved with, working in this field?
Well, there's a lot of technical ability that has to be applied. Our program is not focused on one particular industry sector. We don't, because of where we are in Northern California, there isn't one predominant industry that hires our graduates. That's, by the way, that's sometimes is the case because there are other mechatronics programs throughout the country. Some of them are located in areas where there is a single primary industry. Central Minnesota has a lot of the packing industry. But in California, we're very diversified. So our program doesn't teach a skill set specific to one particular industry. It really lays the foundation so that people understand the fundamentals that are utilized in all those different industries, whether it's food preparation, beverage manufacturing, elevator maintenance, etc. And then the idea would be that when they get hired, that the company that hires them will bring them up to speed in the specific tasks and skills that are needed for their particular enterprise. And we engender in the students this idea that you're not going to be doing the same thing, day in and day out. In fact, it's one of the beauties of mechatronics is that where a lot of automation systems that are used to manufacture products have machines doing that work that people used to do. Putting a piece of material under a machine and pulling a lever and having it perform some task and doing that 8 hours a day, 40 hours a week. Those jobs are gone. Thank God they're gone. We would never want anyone with a college education to do that work. So those kind of repetitive, boring jobs, they're gone. What's replaced them, however, are the folks that are responsible to keep all that automated manufacturing that's done with computer control now alive. And since it's complex, since it can fail, and since it's mission critical to getting product out the door, these technician folks have to have a lot of skills and bring them to bear. And it's a different challenge on a daily basis. The food processing industry has a different set of skills than beverage manufacturing. The elevator and escalator maintenance is a different skill set. So, but they all have certain fundamentals. They all have mechanical devices which usually involve an electric motor as the prime mover. So there's a whole variety of those in play. And what used to be done with cams and pulleys and gears and belts is now being done with pneumatics and hydraulics under computer control, with sensors to determine what's happening and stop if something's wrong. It's really exciting. And these are good paying jobs. These are jobs that are the beginning of someone's career. My role at Sierra College at a very fundamental level is my job is to turn students into taxpayers. And, the community colleges have basically two fundamental purposes. Their reason to be is to be both an institution for transfer for someone that's taking the first 2 years of their undergraduate education and then move on to a university. And there's a large cohort of students that do that. And then there's the other side of what community college is, which is what's called today career technical education. And that's what mechatronics falls under. It's one of the career technical education programs. And I'm very proud of what we have developed at Sierra College. We're really the only mechatronics program at a world standard level in the state of California. And there are 113 community colleges. So one might ask, well, why is it that with the huge demand for people with these skills, there aren't more California community colleges that offer mechatronics? Well, part of the reason is kind of what your question alluded to. People don't know what mechatronics is. And frankly, higher education, in the world of higher education, tradition is a very strong force. So developing a whole new instructional program that had never existed before is a big, big challenge. The equipment is, to teach it properly, is difficult to come by because there's so few programs. So you either have to make it or design it and have it made for you. The skill set required for people like me to teach it is a unique skill set. It's because you have to have electronics background, electrical background, mechanical background, computers and programming background, all available to offer a program like that to students. And we have about $1.5 million of training equipment, both at our Rockland facility, our Nevada County campus facility, and as well, to a little lesser degree, at the Tahoe Truckee facility, where that equipment is available for students to really get a hands-on learning experience in mechatronics, because nobody learns this by just listening to me yammer on about it. No way. This is a kind of an instructional program that requires a lot of laboratory experience and exposure, and it's really where the action happens. The lab is key, and so students spend a lot of time in a lab doing laboratory experiences that very much mimic what they would be doing on a job site.
Well, I'd be remiss in recording this in July of 2020 and not ask about your challenges transitioning to remote teaching.
Yes.
Lab time is a significant part of the course.
It very much is. And, it's really been a major, major challenge for us. However, much to the credit of Sierra College, our program is considered to deliver what are called essential services. And that's because we provide the workforce for what keeps the infrastructure and technology businesses alive in our region. And so as a result of that, this coming fall, our classes are going to be offered in a hybrid mode. And what that means is that the lecture portion of the class will be one done in a way very similar to this right here. I'm going to videotape my lectures and my demonstration stuff and post those on my YouTube channel. And then the students will come onto the campus, and they will be doing the lab experiment element of those classes on site. So they'll be on campus 2 days a week, doing 2 different labs for each of those. And they'll have an opportunity to watch the lectures on as a video delivery. And the nice thing about a video delivery, of course, is that if I make a mistake, I can go back and edit. If the student wants to take a break and go use the restroom, they can come back where they start where they left off, or they can, review a portion of the video and watch it maybe several times if there's a part that they didn't get the first time. So there's some advantages there, but it's challenging, and it's not the same thing as a real interactive classroom environment. But we're going to make the best of a really challenging situation that we have these days. But thank goodness that we're going to be able to provide the laboratory portions on ground, because as one of my colleagues said, the challenges that students encounter and overcome in lab, that's where the real learning happens. So I'm pleased that we're going to be able to do that.
Well, that's just fantastic. Now, Sierra College is the local community college for the Nevada County, Placer County region. How does the mechatronics program contribute to our local economy right here?
Yeah, before you invited me out here today, I was looking over this list that we have posted on one of our bulletin boards at the Rockland campus. And that list is about 8 feet tall of all the companies that have hired or are currently hiring our graduates. And many of those companies are in the Nevada County area. Just to name a few, some of our graduates have gone to work for Huntington Mechanical. Some have gone to work for Nevada Irrigation District. Some have gone to work for Autometrics. Some have gone to work for High Sierra, which I don't think they're in business anymore, but they were around for a while. We had students work ultimately for National Semiconductor, Linear Products, they're still around, and a host of other companies. And many years ago, it was the Grass Valley Group, J&L Video. I may have the initials wrong on that one. AJA Video. Yes, thank you. So these are companies that have a need for students with our skill set, and that's just for Nevada County. But we're really get companies from all over Northern California to come out and pitch their jobs to our students. I mean, just to give you some clarity about that, we host our own job fair twice a year, once in the fall and once in the spring. Now, we weren't able to do that in this last spring because of the pandemic, and it's going to be challenging to put it together this fall and spring if we're still in the throes of it in a big way. But we generally have between 10 and 15 employers who come to the campus, and they set up a table with a drop cloth and brochures and stuff that pens and pencils and letter openers and all that, the typical things that you see at a convention. But they're there to pitch jobs to our graduates. And our graduates are there dressed up in clothes that I've never seen them wear before. And many of them have haircuts and have shaved in a way that I hardly recognize them. But they're there with their resume, and they're looking to make the connection between the employers that are seeking their skills and their interest in getting that first foot in the door. And a good example of that would be Sierra Pacific Industries. Most people don't even know when they walk into a Lowe's or a Home Depot, where does all that lumber and plywood that's stacked up come from? Well, Sierra Pacific Industries is one of they may be the largest private landowner in the state of California. And their job is basically to turn logs into lumber. And they have these highly automated lumber mills that are scattered throughout Northern California that need people with mechatronic skills to keep that production happening. There's a company that hires our graduates that makes a machine that's used in food processing. So, California, let me be specific here. We're very close, of course, to the capital of Sacramento, sometimes humorously called Sacatomato. And the reason why it's called that is because tomatoes are one of the main agricultural products that are grown in the Sacramento Valley. And if you've ever driven down the interstate during the months of August, September, and October, you see these tractor trailers pulling these ginormous tubs filled with ripe Roma tomatoes that are going to be turned into tomato paste. Well, how does that happen? Well, there's a company located in Winters, California, that is the largest processor in the world of Roma tomatoes into tomato paste. And they have this highly automated facility that takes the tomatoes and that are dumped out of the truck with all the rocks and stems and other kinds of contaminants. And when after the tomatoes go down this washing area where they're in a conveyor of water like a trough, they eventually come out on a conveyor belt where they're zoomed along at about 30 miles an hour. And when the conveyor belt gets to the end, tomatoes go flying off the end of the conveyor belt. But just in front of that is a machine that has these little fingers where a high-speed video camera is watching the materials coming off that conveyor belt, and anything that doesn't look like a ripe tomato gets knocked down into a reject bin, and everything that's cool, that's okay, just continues to go on. I mean, these little fingers that come and knock down the contaminating materials, they move so quickly you can't even see them. I mean, you can only see them in slow motion, and that prevents the need for there to be, hundreds of people watching tomatoes going by and picking out all of the non-tomato or unripened ones, or ones that have gotten crushed or whatever, which is, of course, is the way they used to do things. But who would want that job? 8 hours a day watching tomatoes go by. And when people do that work, even when they were at the peak of their capabilities, you don't know if the people that came in to do that work just had, a fight with their spouse, or was hungover from the previous night of partying, or is thinking about who's going to win the Super Bowl next week. There are all these things that really limit a human's ability to concentrate on work like that. But machines don't care who wins the Super Bowl, and they don't have fights with their spouses, but they do have these very complex mechanisms that leverage mechatronics. And so the company that makes those machines hires our graduates to go out and do the installation and field service for those machines. And that's just one of several companies that hire our graduates that need folks with those skills.
Very cool, and that's a real local type position too.
Indeed. So it's not just Nevada County, it's not just Placer County. One of our graduates went to work for a company that manufactures and distributes automation products. It's actually the SMC company. They're a Japanese firm that manufactures primarily pneumatic controls, air-operated cylinders and valves and all the associated parts that go with those. And so maybe instead of working as a technician, this person became a salesperson and just really excelled, had really good people skills. So there's a whole plethora of different positions that someone could leverage with this set of knowledge and skills, not just simply fixing things or repairing things, although that's what a lot of it can be. And to kind of take that one step further, I'm going to anticipate a question here.
Yeah.
So what kind of students typically are attracted to mechatronics? And it's the people who have a kind of natural curiosity about what makes things work. So if you walk up to the entry door of a supermarket, and as you get within 10 feet of it, it opens up to let you in and closes behind you. You've ever wondered, how does that work? That is the kind of thing that, those are the kind of students, people that really tend to thrive in a mechatronics program. They're just interested in how stuff works. And that's really a good skill, a good background to have. But if someone likes to tinker around with fixing things, like if you fix your own bicycle or your skate or your skateboard, or work on your car, or fix appliances at home, if you tinker around like that, if you find that to be, fulfilling, this is a way to turn that love into a career and learn a lot more about the skills that are needed to really be productive in that space.
Very cool. Now, you're discussing many different types of jobs and positions here. How do you prepare students to be able to jump into this wide range of employment?
Yeah, I think it's worth noting that we don't have, even though, as I said a moment ago, students who have a natural curiosity about things tend to really excel in mechatronics. That isn't to say that if you don't have that curiosity, it's a deal breaker, not in any way. But the point is that we don't assume that anybody that steps into our program has any previous knowledge, skills, or ability. We assume, and just the opposite, that they come in completely skillless, knowledgeless. That's a word. That they're a blank slate, if you will, and they don't have. Well, in a way, there's a good thing there. No bad habits, but we start very quick. We start with very basic things, and we build, but we go quickly. So in one class, for example, we start out at the beginning of the semester with, what is mechatronics? Why should I care? What do people who know mechatronics do with this skill? And then we get into electricity and how it is created and how it's distributed, how it's delivered, how you can handle it safely if you take into account appropriate precautions and apply the right techniques. And then over a period of semester, we get into electrical controls, and then we from there into logical control systems that are the way computers work, but not with using computers, at least initially. And then talk about motors, because they're the prime mover in mechatronics, and all sorts of different kinds of motors. And even though we work with relatively small ones, because we have the constraints of the lab that we're working in, the principles by which motors work is the same, whether it's a little one horsepower motor that you can take apart, see how it ticks, and put it back together again and verify it works, to one that's 1,000 horsepower. Both AC motors, DC motors, specialty motors like servos and steppers, and then beyond motors, we talk about sensors and how there are ways to let electronic devices mimic what humans would do with their eyes and their ears and their sense of touch, and then move into how all of that is applied in a system. So we have a set of trainers that are a little miniature automation system. My colleague and I designed these several years ago. We had them built for us by SMC Corporation. They're, as I mentioned their name earlier, and they have at their heart, or at their brain, if you will, they have a computer, a specialized industrial computer called a PLC. And my students learn how that computer interfaces with all the sensors on the input side and the switches from the human control panel called an HMI, human machine interface. And then on the other side of the computer, the outputs that control the actuators like the air valves and the motors and the indicators like lights and so on. And then they learned about how to program that device. And that is, in a nutshell, a one-semester class for someone that has absolutely no previous background in mechatronics. So it's a really huge quantum leap from knowing nothing to being able to actually program and troubleshoot a mechatronic systems that has all those constituent elements that we talked about earlier in the semester. The controls, the electricity, the power, the sensors, the actuators, everything. It's really fantastic. And that's one of the reasons, again, why our program is rather unique, because those trainers are expensive, and we have a whole set of them, both at the Rockland campus and another set of them at the Nevada County campus. So there's the Sierra College, much to its credit, I think really realized and took to heart the fact that we were a program that was actually very successful at converting students into taxpayers, providing the set of skills, the foundational skills that someone would be sought to know, would be sought after by employers in the area. And so we did get some grants from the state of California, but we've also had really excellent administrative support to keep our program running. We have remarkably dedicated staff, both full-time and part-time. We have full-time lab technicians, beautiful facilities. And, you know, and I would encourage you watching this video that if you want to take a deeper dive into the mechatronics program, there's a couple of places that you can look. One of them is you can look on the Sierra College website, and you'll find us in the area of career technical education. But we also maintain our own website as well, called realskillsrealjobs.com. It's all one word, realskillsrealjobs.com. You just Google college mechatronics, you're going to find us there as well. And on that website, we've got a very, I think, clear description of what our program is all about. It shows the equipment, the student projects, what the laboratory looks like. It introduces the other instructors. It also links over to a Robotics Club that we sponsor. So students that are, you know, when I mentioned earlier that when people ask me at a dinner party, you know, what's mechatronics? And my standard answer is, well, it's, you know it as robotics or industrial automation. As soon as I say robotics, I can see on their face they know what I'm talking about, because they've seen the commercials on television of, you know, an automobile assembly line with the big, you know, KUKA robots coming in there, or FANUC robots building something, you know, on an assembly line. And yeah, that is robotics. But the cool thing about robotics is that there are a whole bunch of people that build robots that fight each other, combat robots, or they build robots that can solve a problem, like to figure out a maze to get to something at the end, for lack of a better word, a reward at the end of a maze. And, you know, our Robotics Club has been very successful in both arenas, pun intended there, for both the combat side and for maze solving robots. And it's totally voluntary. Students that are in our program, if they want to get involved in Robotics Club, they can. If they don't want to, that's all right as well. But it's a good way of developing a camaraderie, really what a college education, in my opinion, is about getting together with your peers and solving problems. And building robots involves so much of a complex problem set that you really need a lot of brain power from a variety of different folks to really be successful.
Now, earlier when you were discussing everything that you do to help prepare? You mentioned, and this is all in one semester. How many semesters does the mechatronics program run for? How many hours a week roughly?
Yes, well, if you go to our website, or if you go to Sierra College, you'll find that we have both a mechatronics degree and a mechatronics certificate. So the degree and the certificate are really the same set of classes, which I'll mention in just a moment. But the difference is that a degree means that someone's taken both our set of classes as their major, but have also taken all the general education classes that someone needs to get an associate's degree. And that would be the English, math, social science, etc., those kinds of humanities, the things that make someone deemed to be college educated. But there are people that either have that already, or they're switching careers, and they want just the skill set of mechatronics. And so for that, we have a certificate. We actually have two certificates, but the main certificate is made up of 8 classes, and that certificate can be taken over a period of, well, typically 2 years, 4 semesters. So if you just do the math, you've got 8 classes over 4 semesters. You would typically be taking 2 mechatronics classes per semester for the fall, spring, and then again fall, spring, and then you would complete our program. Some people have done it in 1 year. Now, that is a rather tall hill to climb, but there are folks who, have cleared out all of the other constraints on their lives and have been singularly focused on getting their mechatronics certificate as quickly as possible, and they've been able to do it in 1 year. And it's a challenging course of study. So this is not easy stuff. It's nothing it involves things that students have never typically taken in a educational environment before. But we are very much a project-based, hands-on style of learning. It is not just listening to me and my colleagues yammer on for hours on end so that you can take notes and check the boxes on a quiz. It's nothing like that at all. Yes, there is, of course, lecture material. There is some reading to do, but the real magic happens in the lab. Everything focuses on the set of skills and the knowledge to accomplish a task, a problem that needs to be solved in a laboratory environment. So the beauty of the community college, too, is that we, particularly in California, we are the world's best deal when it comes to higher education, because the cost of our classes is ridiculously low. And we don't charge a lab fee for our materials. So, and most of our classes don't have textbooks. And that isn't because we're averse to books, but it's because no one writes books for mechatronics. Why would they? There's so few programs in the United States that would have their students buy that books. If I was an author, there'd be no market to sell books. But the beauty of mechatronics is that the internet is a vast resource for knowledge and information related to the elements that make up mechatronics. And then, of course, a lot of equipment has manuals that if you read them, you can actually find out how things work. And so we don't usually have a lot of extra costs that are incurred by students other than for the cost of the class itself. So it's it's a bargain. And our students, when they go out and become gainfully employed, they're working for living wages. They can go out and they can, you know, raise a family, buy a house, you know, have car payments, be in debt. The great American dream, you know.
So we talked a little bit earlier about how people that are really interested in how things work tend to be attracted to this type of thing. What else do students need to excel in this program?
Yeah, I think that, you know, I want to make one other point before I answer your question, and that is that, you know, if the people that are watching this are not necessarily the folks that would be interested, you, of course, want your prodigy to be able to achieve in life is to be economically self-sufficient. A supporting career where you don't have them living in your, you know, in your spare bedroom for the rest of their Mechatronics provides the set of skills that someone can acquire that they can use to start their working career that will allow them to be self-supporting. And to me, that rings the bell. And when students get jobs in our program and we find out about it, that really, both figuratively and literally, that rings the bell in our world. We actually do have a bell, kind of like the tip bell in a bar. And when a student gets a job, we ring that bell because that's the goal of what we're about. Now, your question, which was, if you'll help me again, I guess I went off on a tirade there.
Oh, that's
Give it to me
just
again.
fine right there. What do students need in order to really excel in this program?
Yes. So what do they need to bring to the plate? So first of all, it's a college class. So there's a certain level of decorum that's expected, and it's important that students pay attention. There are things that students do in the world of mechatronics that ultimately are mission critical. What I mean by that is that people's lives are at stake. If you are working as a lift maintenance technician up at Sugar Bowl or at Squaw Valley Ski Resort, and your job was to maintain some piece of equipment that was part of a chairlift, well, there's hundreds of people on that chairlift who are hanging on that cable. It's called actually the haul rope, and their lives are in your hands. So I think that we expect people to bring a level of seriousness to their to the learning process that they are involved with. Also, we work with electrical systems that are potentially lethal. I mean, this is not just low voltage stuff. This is high voltage stuff. It's 280, 208 three-phase power. If you could be killed if you are not, you know, aware of it and how to deal with it properly. We have had nobody who has been even minorly injured or certainly not killed in our program. But the point is that that's because we go to extraordinary lengths to make sure that students work safely in this lab, so that when they go to work, they bring that same culture of safety with them. So I think it is, you know, a long-winded answer, but I think there's a certain degree of seriousness involved. There's a dedication that's needed, because about an equal amount of time that's spent in class is expected for students to work outside of class, doing some homework assignment or some research. And that's not just homework and busy work. That's not just research for the sake of, you know, filling out a term paper. That's not what it is at all. It's just that there's not enough time in class to cover necessarily everything at the level that is required to drill down deeper than just a more superficial approach to things. So that's why the internet becomes such an excellent resource, So I can tell a student, as part of an assignment, to research, for example, the application of servo motors in automatic labeling for packaging and beverage and container manufacturing. And they will find those videos and view them, and they will have a better picture of what these elements of mechatronics are used in. So I think that that's another part that's important. Of course, we do have quizzes, we do have tests, we do have practical labs that have to be done, but that's not really as critically important as students being able to take what the skills that they have learned and apply them in the workplace. I mean, this is, I don't know, maybe I'm being overly long-winded here, but this is not like a history class, because no employer is going to ask you, when was the War of 1812 fought? But they will expect that you know how to read schematics and pneumatic diagrams and look in a manual to find a repair or maintenance procedure, or how to perform periodic maintenance by virtue of a set of instructions that were dictated and printed by the manufacturer of a particular machine or an element within that. And so, yeah, this is important stuff that someone's going to hire you as a graduate of our program, probably have you working along somebody else for a while to learn some of the specifics of that particular industry. But then at some point, you're going to have to go from being a liability to an asset. And that means that you can bring value at an enterprise on your own. And it's a lot of self-teaching. I tell my students, same thing I'm going to mention right here. The learning never stops. This is not like in the old days of automation, working in a factory going shh, kaboom, for 8 hours a day, 40 hours a week, and thinking about anything else except what you're doing. This is completely the opposite of that. Every day, every week brings a new set of challenges, and you just have to be committed to lifelong learning. You have to be excited about learning new things and building that skill set where you're feeling more and more confident about dealing with things that you've never seen specifically before, but you've seen something similar to it, or using the principles that you've seen used elsewhere, and applying those skills with some insight to the task at hand. It's really a wonderfully challenging career.
Well, you went ahead and answered a couple of my other questions.
Okay.
I'm just going to go ahead and look in YouTube here and see if anyone was asking any questions. Looks like someone says the Robotics Club is great, so you've got a fan watching.
Yes, and the Robotics Club actually has its own website. So if you want to check out, and there's some cool videos that show some of the things that they've worked on and been involved with, go to our website of realskillsrealjobs.com, and then there's a link there to the Sierra College Robotics Club, or you can simply Google Sierra College Robotics Club. And there's some YouTube videos as well that are available that show things that both we do in our program as well as what the Robotics Club is all about.
Cool. I'll have to get them from you and post a couple of those links in here.
Okay.
I guess we're getting close to the end of our time here. So I want to ask if there's any kind of closing thoughts you want to impart to us.
Well, that's almost the toughest question of all. I don't usually find myself speechless, as you can tell. Here's the thing that I think is worth mentioning. What makes our program successful is that we're constantly changing it. It's not fixed in one place I mean, as a teacher in the program, I am envious of someone that teaches like the history of the Civil War. And maybe it gets boring after a while, I'm not sure. But there's certainly a comfort level to coming in to a classroom and teaching the same thing year after year after year. And I get that. And there's obviously good reason to know about the Civil War. On the other hand, our program is the antithesis of that, because we have advisory committees that we meet with twice a year, where we solicit feedback from the companies that employ our graduates, and we also solicit feedback from the students that have left our program and have gone out and worked for those companies. And we ask those very important questions. You know, what were you expected to know on day one? And where did you feel highly confident? And where did we miss the mark? And if there's something where we see a consistent hole or missing element in our program, well, we just change our program and fit that in. We just recently added a new class to our curriculum so that students can learn about designing and fabricating 3D in 3D printing. We didn't have that in our program up until just recently, but our employers told us that our students now working for them should have those skills, because sometimes they're needing to make some little fixture or a bracket or a holder or some part that they need immediately, and they can build something temporarily using a product like Fusion 360 to do the computer-aided design, and then port it over to 3D printing, and how to use a 3D printer and properly make that part. And it's just a really good skill to have. So I think what I'm saying in so many words is that our program is constantly in a feedback loop of looking to see what it is that we're doing right, but equally important, looking to see where we could use some improvement or needing to add or change something, and we respond to that change, which is why, arguably, we're the best mechatronics program in the United States.
That was just fantastic, Mike. Thanks so much for tuning in, folks. It's David Carroll with Nevada County Tech Connection. We had Mike Halbern from Sierra College speaking with us tonight. This was our inaugural TechTonic TV. Thanks for bearing with any technical hiccups. Till next time.
All right. That was
whacked
great.
my microphone twice.
I'm going, I want to sign up again. I go, no, I'm retired. Stay retired.